real quick, before we move on to the next thing, I've been holding this thing about the train. I just wanted to add one little thing to that. So,
Yeah, you were cooking on that debate review, Piezo. I was like, whoa, this man getting to it. But yeah, go ahead, continue.
thanks, bro. Yeah. So the train, like the setup with a receiver, like a lightning rod at the front end of the train, a lightning rod at the back end of the train, right? And they try to make the crux of the argument the fact that the signal, like from the lightning rod, electricity in a wire, has to travel through the wires, through the train to the middle. But you can very easily, like, even remove that part of it too to make it even much simpler to think about, because the real argument here is not about a relativity of simultaneity, about two events not actually taking place simultaneous. It's about the observations of the light that travels to you not getting there at the same time based on it having a travel time. And so if you just think about the experiment in terms of, imagine the same setup, train, lightning rod at the front, lightning rod at the back, but each lightning rod is attached to a little like a hammer. Not a hammer like you hit a nail with, but like a hammer, like a lever with a switch. And when the lightning rods get struck, the hammer falls and the switch flips, right? And it pushes up on a horizontal bar, a balance beam that's running across the entire floor of the train. And the midpoint, right? The midpoint of that has a little we'll just call it a little rod on it that's very thin and vertical. And if it pushes up perfectly vertically, it hits the bottom of the bomb and explodes the bomb. Now, if the lightning rods are struck at different times, then the hammers will fall at different times. The switches will get flipped out of sync, and the balance beam will not get pushed up perfectly vertically. It'll be tilted to one side, so the little activating mechanism will not activate the bomb. So by doing this, you make it a mechanical system with zero delay, and you don't have to argue about the electrons traveling through a wire to get to the midpoint of the train. It literally just depends on actual simultaneity of the lightning strikes. Okay, so then you're only talking about the difference between the observer's view of an event and the actual event itself, right? And that's actually what the argument is about. It's about, is the actual occurrence of an event the same thing as the observation of it? And the answer obviously is no. An event happens regardless of how you observe it to happen. It happens on its own because it is what it is, right? Like, that's the reality. If someone smacks a drum with a drumstick and I'm on the other side of the football field and the band's playing over there, it takes a split second for that to get to me. It doesn't mean that they hit the drum when I heard it. They hit the drum before I heard it. But the drum was hit at one definite point in time. Just like with light, it's the same exact thing. When the lightning strikes, it strikes at one definite point in time. It might take the light a second to get to my eyes, but it still only happened at one moment. You can't have two events. You can't have it happening at two different times, right? It has to happen at one time. It's one event. And so if at the moment that the midpoint of the train is perfectly lined up with the observer stationary on the ground, if the observer stationary on the ground sees the lightning strike simultaneously at the rods, it happened simultaneously. And so the bomb would blow up regardless of what the people on the train see. That shows that there's an absolute frame and that it happens with respect to that absolute frame.
So is that the main contention, Piezo? Is that in reality we measure against this absolute frame, but in the science community they measure against light and need it to be constant?
Yes. So basically what they're doing, right? There's an absolute frame. That's what all measurements are taken against in reality. Anytime we measure something, we're measuring it in the reality that we live in the frame that we reside in. But with light, right? Light's a wave. It has a travel time just like every other wave. With every other wave, when you got a motion between the source and receiver, it creates a delay. and you perform a Doppler shift, right? There's a Doppler shift that happens to the wave. But with light, they arbitrarily decided we need to make it constant no matter what. So instead of Doppler shifting the light wave, we're going to use the Doppler shift formula, and we're going to Doppler shift the fabric of reality, and we're going to perform a Doppler shift on space and time itself while keeping light as the constant instead of reality. So it's just an inverse Doppler shift that they did. Instead of shifting the wave, they shifted the world. So that they could keep the light constant. Because if they didn't have constant speed of light, if C wasn't C all the time as they say it is, they would never be able to use light as a universal yardstick for the sky to tell you what's happening a bajillion miles away and what it's all made of and how big it is.
I was going to ask you, what are the consequences if they don't have C as a constant? What is the and that's that right there that's the problem. They needed to explain these phenomena.
Well, no.
Right.
Well, hang on. So I don't agree with that was all stated as fact, and I don't think I agree with any of it.
I didn't ask if you agreed. That's fine. You don't have to agree. You never do anyway.
Well, I'm just saying it's not fact. You're presenting it as fact, but that's not the case. So, for example, the speed of light comes out of Maxwell's equations. If light does not have a specific speed, then everything we know about, light from the behavior of the electromagnetic spectrum is wrong, which means none of our technology would work. So
you're right, but once again, that's based on the properties of the medium through which the light wave travels, just same as any other wave. There's a certain speed for a sound wave. There's a certain speed for a wave in water. You can take the velocity you can find the velocity of a wave by multiplying the frequency times the wavelength. Mm-hmm. C equals lambda f, and that gives you the speed. Okay, it works for light. It works for any wave. And go ahead.
No, I mean, yes. So light has to have a specific speed, and then the test, which started with Nichols and Morley, came to the fairly jaw-dropping conclusion that it has the same speed regardless of what reference frame.
Well, hold on. Before you jump there, let's stay on where we're at. We can move there. That's fine, but let's make sure that we have this ironed out because, you claim that what I said was incorrect. If light's got a constant speed, that's constant based on the medium once again, right? To me, because a wave in and of itself is nothing. It's just a vibration, right?
No.
Please don't cut me off.
Oh, you just asked me a question.
I'm still talking. So a wave is not anything in and of itself. It is just a disturbance, a vibration, a perturbance in a medium. There's a wave speed in air. There's a wave speed in water. There's a wave speed in all kinds of different fluids, right? You can calculate what it is for whatever fluid you want to pick. But the fact is that they all follow the same set of equations for their behavior. And if you know the properties of that medium, you can then calculate what the speed will be plus all the other variables. Now, if that medium through which the light is moving, if there is relative motion of that medium or between the receiver and source, either way, it's the same thing, Galilean relativity, right? Then your velocity will now be the velocity of the wave plus or minus the relative velocity between the emitter and source, or the Doppler shift equation of that. And so that is what you do with every wave, like I said. But then they said you don't do it for light, and that's where you get into Voigt's equations, Voigt's and Lorentz's equations that Einstein copied and used in his theory. That's where that comes from. It's actually a Doppler shift. That's what they did. Except they just didn't Doppler shift the light wave, they Doppler shifted reality.
Okay.
So you should look into it.
Are you going to keep talking, or
no, I'm finished. You should look into it.
I have. So I have a question about the first thing that I disagree with, that you said was that if you have a physical hammer that falls when the lightning hits, it will, somehow clear all of this up. And that's not true. Whereas the logic that determines if those two hammers fell at the same time has to be somewhere. right? Presumably, it's with the bomb in the middle of the train. Yeah.
There is a horizontal metal bar, okay? Horizontal metal bar stretching across the entire length of the train. It's balanced. We don't need to talk about the balance mechanism. We'll just say it's free floating, okay?
Mm-hmm.
But if it's free floating perfectly level, in the exact center of it, there's like a tiny little detonation pin where that detonation pin, if it gets pushed perfectly into the little slot that it just fits just right in the bomb, it'll explode the bomb. So the idea is that when that hammer falls, it's going to hit that balance beam.
So
now, if the left end of the balance beam and the right end of the balance beam are hit perfectly simultaneously, then the whole thing will remain. Dude,
faster.
It will remain.
Please.
Dude, you're not going to sit here and rush me, bro. Like, I'm talking. You need to stop interrupting. It will get hit with the hammers, and if it gets hit perfectly simultaneously, it will remain horizontal and level, and the little pin in the middle will go into the slot for the bomb. If it does not get hit perfectly simultaneously on the left and right ends, then one end will go down before the other, it will not remain horizontal, and the pin will not go in the bomb, and it will not detonate the bomb. So when the lightning strikes, if it is truly simultaneous, it will blow the bomb up, and if it's not truly simultaneous, it will not. You don't have to worry about electrons traveling through a wire anymore. It's just the one event. When it happens, snap your fingers, bam, is that simultaneous.
So that was a lot of... So part of talking to people is having like a back and forth. And if you just go on and on and on and don't pause to let the other person interject, then it doesn't work, right? So first off, that bar can only respond at the speed of sound in that bar. That's as fast as any compression or anything can move through it. So no, that just makes the problem worse. But
we're gonna
wait, just one second. No, Piezo. No, the bar is not perfectly rigid because it exists in real life. So no, you can't do that. But
trains don't
because
go near the speed of light.
Now you're interrupting me. Okay.
Hold on, Piezo. Let him finish. Go ahead, Omni.
Well, hold on a second. We could go ahead, but if what I say is 20 seconds, and then I ask for a response, and then what he says is 20 minutes, and then says you can't interrupt me, that's no good. I'm not up for that. What I have to say is
I don't give you time to cry, man. I'm saying go ahead and make your point. I moderated already. Go ahead.
Yeah. Okay. So that's it. So no, you don't get a perfectly rigid bar. That doesn't solve the problem. It doesn't resolve anything. You've just made up something. You've made up another thing to include in the thought experiment to suggest that this problem won't happen. But no, you can't do that. If light and electrons have to travel, so does the rigidity of the bar. It doesn't work.
Yeah. So now you're going to dictate to me and say that's no fair. I'm not allowed to have a perfectly rigid bar. I mean, I gave you a train that goes near the speed of light. That doesn't exist either. But I guess that's okay though, right?
Well, we agreed on the train going at the speed of light. We don't agree on the rigid bar.
Yeah, it's a thought experiment. If you don't want to step into my thought experiment because it damages your paradigm, that's fine, but you can go complain somewhere else. It's my thought experiment, not yours.
No, I'm fine with stepping into it, but this idea that there's some physical solution that you don't have to worry about the nasty electrons is just nonsense. Your solution is I now have something that moves faster than the electrons because I have declared that I have a bar of unobtainium that will magically do this.
Okay, the bar is quantum entangled from end to end. There you go. How about that?
Doesn't work. No, that won't work either. What do you think quantum entanglement is? How do you think that works?
Omni, I'm not playing this game with you, dog. You're not going to sit here and tell me I'm not allowed to have whatever I want to have in my thought experiment.
Because I know how rigidity works in solids, and because I know how quantum entanglement works. Yeah, I imagine you don't want to sit here and do this with me.
It's a thought experiment. Thought experiment, Omni. Yep. It's all made up to begin with.
But so what Peter said about how these thought experiments work is that they work as an internal critique of the of the scenario. So you don't have to carry out the experiment. You say, is there a violation of causality, the causal ordering postulate, where a effect precedes a cause, or is there a effect of two different results seen from different reference frames? And the answer is there's not. The video that whoever it was played, the audio of it, agrees with that. And you can put whatever you want in the thought experiment, but we both have to agree that the thought experiment, that we both have to agree what goes into it. You can say I have this perfectly rigid bar, or I'm making up some new kind of quantum entanglement, but that no, I don't agree to that. But I will agree there's a train with a bomb on it. That we both agreed to that.
Okay, so you're talking about I'm not allowed to invoke a bar that violates the relativistic definition of causality. But relativity is what we're debating here. I don't accept your definition of violations of causality, because for you, violations of causality is anything that goes faster than c. I know of plenty of examples of things that do that, so I don't accept that premise to begin with. You can't use the thing being argued as a substantial basis to defend itself. That's circular reasoning.
No, that's not what I'm doing. What you can't do is say, oh, well, you say nothing can go faster than light, so I'm making up this hypothetical thing that goes faster than light. The question of the question of the paradox is, if two different observers in different reference frames perceive an event as simultaneous or not simultaneous, does can you have an outcome where the bomb does not explode and one where it does? That's the paradox. And the answer is, when you do the math for it, you don't have the paradox. The bomb doesn't explode, even though the person on the platform sees the strike simultaneously. The bomb, traveling with the detectors inside the train, does not see it simultaneously. And the train doesn't have to be going at the speed of light either, as long as the transmission would have to be at the speed of light.
So answer me this then, since you're trying to make it so complicated and you won't even buy into a thought experiment to answer a thought experiment for a paradigm that's not testable, the effects of which are not testable. When the lightning strikes the two rods, okay, do you believe that the occurrence of the event is separate from the observation of the event, or do you think that events can only happen as observed?
I don't understand the question, but
if the lightning strikes at one point in time,
I don't think there's one point in time.
Yeah, exactly.
Right.
You believe that time is not constant, it's not continuous. You believe that space is not constant, it's not continuous. You believe the only thing in all the universe that's constant and continuous is light. And well, maybe not continuous, but constant. Everything else in the universe warps and bends because light is its universal dictator and ruler and changes everything else around it. You think the fabric of reality itself is subject to change more than light.
So that was a good rant about telling me what I think, but you need to work on your internet.
Do you disagree? Yes or no?
Yes, I disagree.
So you think that light's not more constant than space and time?
You said a whole lot of stuff, and I did not agree with all of it.
What about that specific question? Do you agree that light that can't bend and warp what space can? Like,
I think that light does, in fact, that gravitational lensing is a thing. Yes, something we observe.
Okay, so you agree with that?
Is more constant than the fabric of space and time itself.
What is it? Say again.
You believe that light's velocity is more constant than the fabric of space and of time itself.
I wouldn't say so, but what I would say is the speed of light is the fastest rate of causality that we can experience in space-time as it.
Also not true.
Well, that's what I would say. So, trying to put words in my mouth might be better just to ask the questions about what I think.
Well,
What's
give me an
that,
example
Framing,
against that point.
Again,
Or like,
Or
no,
so
because he said that he doesn't necessarily agree that the velocity of light is more constant in space and time. So what's the inverse?
it's that there's the velocity of light, the speed of light in a vacuum is as constant as space and time because they are directly related. It's not more constant, not less constant. That is the cause of the constant.
You know that there's fluctuations in a vacuum?
Yes.
Hmm.
Those would be the Casimir fluctuations, I would guess.
0 point energy, all kinds of stuff. But the point being,
see, I actually know what that is too. So
the point being that in reality, the speed of light is not measured as constant. It's measured as variant. It has a summation component, c plus or minus v. That's how it's measured. That's what interferometry and radio waves show.
Okay. So what? So you're talking about, I guess, the Sagnac effect.
Different things. We've got the Sagnac effect. We have superluminal speeds of energy propagation. There's lots of things that show that light speed is not constant.
So I don't agree with that. And if we look at them closely, it turns out every time I've looked at it closely with someone, it vanishes in a puff of logic.
But Omni, like you wouldn't. So let's just say that this is the example that I threw out there a couple weeks ago. Me and X was talking about it. If they assume that sound was constant and they experience a variation, wouldn't they say that this time dilated?
Sorry, if they assumed that sound was constant.
Yeah, just like they assume that light is constant, and then when we experience that variance, you say it's time dilated. So if we assume that sound was constant, and then we experience some type of variance depending on the medium that it's propagating through, wouldn't we attribute time dilation to that observation as well?
So it's possible, but it would be based on a bunch of really bad data as opposed to being based on enormous amount of experimentally proven data. So,
but you do agree it only takes one time to falsify a claim, right? Like I don't need the same amount of evidence. All I need to do is falsify a claim once in order for it to be invalid.
Sort of. You only have to falsify it once if the test that falsifies it is repeatable. Just because you say I falsified the speed of light on my home interferometer and nobody else can produce that doesn't work, right? It has to be a test that's repeatable.
It happens in every interferometer, every closed loop interferometer in the world if you move it.
Okay.
So you move an interferometer. Actually, I mean, linear interferometers work too. People just denied that until recently. But if you spin
Wang,
it,
right?
Yeah,
he's call him Wang around here. Shout out to Wang.
Yeah, that doesn't get you there. I know about Wang.
Well, apparently you don't, because your boy Wang showed that the generalized Sagnac effect is what's always been measured.
My boy Wang took out a patent for a device that doesn't actually work. So.
Oh, you're going to say it doesn't work? It sounds like a positive claim. Can you demonstrate that?
Patent ran out.
How does that have anything to do with it not working?
Well, show me that it works.
You just said it doesn't work.
Yeah. Well, my evidence is the patent ran out, and his linear interferometer detecting motion has to be hooked up to another system, so it's not like it works. It'll work in your car.
Hold on a second. If I invoke a patent as evidence of it working, you would say it's just a patent.
Yeah.
But you're allowed to say the patent ran out. That means it doesn't work. What kind of logic is that?
So what kind of logic it is you're claiming that my boy Wang has broken the paradigm, and I'm saying no, not really, no.
Yeah, but we asked you why. You said his patent ran out. So Piezo was saying, well, if we said, hey, he's got a patent for something that works,
Yeah.
and that's proof of why it works because he has a patent, would you accept that?
No. You don't have to.
Don't you see how logically? So don't you see how logically flawed that is? That when we use the inverse of your argument, you won't accept it, but then you use that as your argument for evidence. Don't you see how
almost sacred? You're almost there.
almost?
You're almost.
Go ahead, explain to me.
Close. You don't have to accept my position on this. What my response to was a claim that the whatever mainstream model of science or relativity writ large or whatever you want has been broken by this. And
yeah, but we're not talking about accepting it though. We're talking about your approach to why we should accept it.
Yeah, and if somebody in a debate says, I have this secret knowledge of this new effect that changes everything, and I know about it too, I get to respond flippantly. Yeah.
Yeah, but you think that if you make an argument, the inverse of that argument should be valid as well. But you're saying if you make the same argument where if I had a patent, that means it's evidence of something. Okay, you said no, that's not it. Hold on.
You're close.
Hold on. You keep on saying I'm close, but you're not addressing what Piezo asked you. You said the reason why it's invalid is because the patent ran out. That's what you said, right?
No, that's not what I said.
What?
Not what I said. I didn't say it's invalid because the patent ran out. I said,
what did you say?
I said his magnificent device doesn't work.
So you're playing semantics with Sacred right now? I mean,
no, Sacred is playing semantics with me.
No, I'm not playing semantics. I'm trying to understand what you're saying. So you're saying,
right, so I'll make it real clear.
If a patent runs out, that means the device doesn't work.
No, I'll make it real clear. The claim that was made by Piezo was that Wang had done this magnificent thing, and my response to that was, I don't think so. Just that there is a patent doesn't mean to me that it works.
I never even brought up the patent. You brought it up.
Yeah, I know, but I knew where you were going.
Nah, man. See, this is what I'm talking about. You can't. You just told him that he can't tell you what to say or what to think, and now you're saying, "Oh, I foresaw what you were about to say. You were about to talk about the patent, so that's why I brought it up." And then you try to make it seem like we were talking about the patent. When really we didn't bring up the patent. You said no, it doesn't work because the patent ran out.
Right. So
are you saying if patents run out that means that devices don't work?
Nope. But I'm telling you this.
I don't see the logic.
I have a unique power to read minds over TCP/IP. So,
all right, bro, you're trolling now, bro. You're spiraling. You're spiraling. Like
I'm not spiraling. I understand that. I understand what you think. I've given you my response for it.
Well, because we're listening to what you're saying. That's why we're thinking what we're thinking.
Yeah.
So if you bring up patents and say that object, that device over there doesn't work because the patent ran out, I'm gonna assume you mean, hey, when patents run out, that means that the devices don't work.
Okay.
And if that's not what you mean, then you have to explain the relevance of a patent running.
It's not what I mean, and the fact that this claim device does not exist in any tangible form that we can look at means that I don't find the claims about Wang's breakthroughs in interferometry to be, to be especially impressive. In other words, the fact that he wrote the paper, and it's a pretty good paper, and the fact that he applied for a patent, and it's a valid application for a patent, altogether means very little in terms of proving that the mainstream model of the Sagnac effect is wrong.
But what does that have to do with the patent running out?
Because I know that he was going to the device.
He was what?
He was going to go to the device, to the fact that this was a substantiated claim Because the paper had led to a patentable device.
So devices don't work unless it has a patent?
No,
So devices can work if it doesn't have a patent.
it can't. Could, yes.
Do devices work if patents run out?
They could.
So then why did you bring up this patent?
Because that's where he was going to go, and because the device,
My
assessment, sacred.
What evidence do you have that he was going to go to patent?
I can read minds over TCP/IP.
So you have no evidence.
I don't need evidence. I'm telling you what I'm.
Now you don't need evidence when we're talking about the sciences and devices and how things work.
I don't need evidence that was where.
Now you're just projecting and assuming. Bro, there's no logic behind this, and I'm trying to learn. But if you're just gonna make arguments devoid of, if you're just gonna make arguments devoid of logic, I gave you every opportunity to educate me on how these patents work and why it's relevant to whether the device works or not. And the very ending of all my questions is, I thought he was going to talk about patents. That's why I brought it up. That is the sole foundation of your whole argument, which has no rational logic behind it at all. And it's been relevant to the conversation, doesn't seem like, because you wasn't able to substantiate why it's relevant.
Sacred. You might be new in this space, but I've been around a little bit.
Bro, you don't got to gaslight me. You can address the point that Piezo. You can address.
I'm getting to it.
About what you think about me, bro. You're not talking about what Piezo asked you. Don't talk about me, bro. Don't talk about me.
You know what?
How are you trying to talk over the host?
I'm not talking about you personally. Don't talk about me personally. Address what Piezo said. What is the relevancy to the patents right now? If you don't have any logical answer, then just say it was bullshit and we can move on.
So, Piezo, were you going to talk about the Wang interferometer patent?
Actually, Omni, I just said the generalized Sagnac effect, and then you said, oh, I know about Wang. And then I told you your boy Wang showed that it was generalized, and then you said, oh, no, I don't accept that. And then you're like, the patent ran out. I didn't even have a chance to go anywhere with it.
I know.
Where I would have went was to the actual research that he did twice with the U.S. Naval Research Lab, who were the ones who loaned him the equipment.
Yep.
And collaborated and helped him to perform this research work.
Mm-hmm.
And I suppose you're going. So I don't need the patent at all, because the patent came 4 years after those experiments.
I know. Yes, I know.
Okay, so it was an effect that was demonstrated. It wasn't a device. It was an effect.
Yes.
With or without a patentable device, that has no bearing on the effect being real. I'm talking about the effect. So do you have anything to say against the demonstrated effect in the Naval Research Lab?
Yes. That effect. So the Sagnac, or the Wang device, uses a fiber optic gyro or an interferometer on a moving platform that is attached to a stable platform. And it measures its movement relative to that stable platform. So it does not measure the generalized motion of something on which both the stable platform and the moving platform, the conveyor belt, would be.
Wait. What's the stable platform?
The other piece of it. If you look at
you mean the spinning ring?
Yeah.
How's that stable? It's moving.
It's not moving through. It's not moving through space like the conveyor belt is.
They're moving exactly the same. They're synced up to each other. There's a cable connecting them so that they move at the same rate.
Right. But the point is that what he's measuring is on the conveyor belt. That he's measuring the linear interferometer on the conveyor belt.
You know that fiber optic loop that's wrapped around the little turn dials is attached to the FOG, which is reading it, right?
Yes.
So these measurements are being taken with respect to what?
They're being the measurement of the fog on the conveyor belt is taken with respect to the other piece of it.
And they're co-moving, right? So they're moving together at the same velocity.
No.
What?
Nope.
Oh, so you want to go to the paper right now and show me that loop and that conveyor belt are not moving at the same rate?
Yeah.
Okay, pull it up.
No, I don't. How do we share?
All right, I got it up on the screen right now. Give me 1 second.
And I'll be clear about what I mean before we get while he's doing that. So the part that's not on the conveyor belt, I don't know how to refer to it.
There's a loop,
Yeah.
and the loop is attached via a cable to the conveyor belt.
Okay. So the loop is not on the conveyor belt.
No, it's beside it. It's sitting right next to it.
All right, real quick before you guys continue, if anyone in the audience wants to follow along, I'm streaming this on the side. You can see the diagram of what they're talking about, but I'll also put it up in the space as well. All right, go ahead and continue, lads.
So
One second. Let me try to get to yours. 1 second, Alan. Go ahead, Omni.
So what that means is that if you put this thing in your car, it's not going to detect the motion of the car. It's going to detect the motion of the linear interferometer on the conveyor belt.
Stay in the lab. Stay in Wang 2004. I'm not talking about the patent.
Well, okay. So then, yes, he demonstrated an effect, and it was interesting, but it doesn't fundamentally change anything.
Okay, so
What?
right.
No.
What he showed, let me explain. What did he show? No, let me ask you, since you said it didn't fundamentally show. What was the effect he showed? Because obviously there was a whole point of writing a paper about it if there was an effect. What was the effect?
That he was able to show motion in linear interferometry.
Okay, so, and that motion was proportional to velocity, right?
Mm-hmm.
Okay, so is that allowed under relativity?
Yes.
Really?
Yep.
So then why didn't Michelson-Morley show it?
Because
the Earth's not moving?
Because what he's showing is the motion of the linear interferometer relative to the loop. He's not showing the motion of the relative of the moving fiber optic gyro or the fiber optic gyro on the conveyor belt compared to the motion of a car that it's in or whatever, or some other moving object. It's only relative to the loop, which is why it works.
Relative.
The effective length, though, right? It's not just like it's the whole loop. It's the effective section that's moving. It's not relative to the whole of the loop. It's only relative to the effective length, which is key to differentiating between what you're saying, where in Einstein relativity, it would be relative to some other point, but that's not what's happening here. It's the effective length. So it makes the measurement with respect to absolute space, which is, a violation of the postulates.
So
right?
I don't agree with that.
Okay.
However,
Well,
Wang is probably better at physics than I am. I'll definitely give him that. So I would have to cite other people who have looked at that and their analysis of it.
I could send you some recommendations that were sent to me to try and explain it through the relativistic paradigm. There was a paper by Tartaglia and others in 2014, a guy named Berida in 2020, and then a more recent paper in 2024 that Mordwan linked the other night that we read. They offer no real explanation into how this would work in the relativistic paradigm, and they just set up for a geometrically convenient, transformation. And then they don't apply link contraction or time dilation, obviously, because those effects would be way too small. And these are first order measurements, like directly proportional to the velocity. So it's not an issue of like a relative frame, and then it's a function of the square of the velocity over c squared.
Yes, just so you know, Omni, this picture on Alan's, can you make it bigger again, Alan, real quick?
Yep.
When this loop is stationary, right, and there's light passing through it, okay, you've got when it's not moving, right, when it's not, so the wheel's not spinning, it's got a certain fringe on one side of the loop and the other, okay. Then when it's set into motion, the fringe pattern shifts. It undergoes a fringe shift, and it has a new fringe pattern. So you can see the shift. The shift on one side of the loop, okay, is different from the shift on the other side of the loop. and he's able to subtract and take the difference of the fringe shifts, and the difference of the fringe shifts is directly proportional to the velocity with which the loop is rotating. And he's also able to take it and use it with the FOG to show the fringe shift in the FOG, and they match each other. So he can use the linear equation or the radial equation, and they both yield the same result. Now, the problem is inside that fiber optic loop, right? That's a closed loop that's just rotating around space. You should not be able to move that loop and internally have a difference in fringe shifts that's proportional to the velocity.
So, well, I don't agree with that. So what you've got is a translational velocity, essentially.
With respect to what?
Whatever the loop is, versus the thing moving linearly back and forth on the conveyor belt.
No, that's just the measurement device, right? And so the reason that he has it on the conveyor belt is because that bottom half of the loop with the V arrow pointing to the left, right?
Okay, yeah.
And the FOG with the V arrow pointing to the left?
I don't know if I'm looking at the same thing that you are.
They are co-moving. So what that means is, according to the rules of Einstein, if you go read his 1905 paper right now, if you have two objects that are uniformly co-moving, they are considered to be part of the same inertial frame. So that FOG is in the same frame as that optical fiber. There's no difference. So within an inertial frame, there being no relative motion between everything in the frame, because it's a closed loop, so there's no relative motion in the light path because it's a closed loop. There should not be a fringe shift. Not only is there a fringe shift, there's a fringe shift that is directly proportional to the translational and radial velocities.
So go ahead. When you have a fiber optic gyro and it's spinning, right? And you're moving around with your fog spinning away. Well, not spinning, spinning on a very small scale. You will see a fringe shift proportional to your motion, right? If in a particularly clever way to go from linear from rotational motion to linear motion.
Okay, but once again, the fringe shift is not happening in the FOG. It's happening inside the optical fiber. The FOG is just measuring it, right? And it's moving uniformly so that it can establish the same reference frame, just so you can't say it's a difference based on the measurement device. The measurement device is within the same frame as the closed loop that's rotating. So the fringe shift is taking place inside the optical fiber, which is a closed loop. If you say that one half of the loop, the bottom half, is experiencing a different fringe shift than the top half of the loop, which it is, and the difference of those is proportional to the velocity with which it's rotating, with respect to what is the measurement being taken inside the optical fiber. If you say one half of the loop to the other half of the loop, that doesn't produce anything under relativity.
It does if the loop
with respect to what frame is the loop itself producing a fringe shift.
If the loop is turning, then you will get a fringe shift.
With respect to what?
With respect to the observer outside of the turning object.
So the observer here is the detector.
No, but the observer here is the thing moving back and forth.
No, the observer here is the device that's registering the fringe shift. That's the observer. That's where the fringe shift's taking place, is where the observer's taking the measurement.
Right, so the observer is on the conveyor belt.
Which is co-moving with the loop, so it's part of the same frame.
It's not co-moving with the loop.
It is co-moving with the loop.
Because the loop is moving rotationally. And
the
loop is not on the conveyor belt.
The loop is got a section. Once again, Alan told you it's a segment. It's got a section there that's a straight line on the bottom half, and a section there that's a straight line on the top half. right? That FOG is able to take a segment of that straight section and calculate the fringe shift within that segment. And within that segment, it's all co-moving.
No, I don't agree with that. If you don't have if the fiber optic loop isn't a loop that is subject to the Sagnac effect, and if you don't have it connected to the device on the conveyor belt, then I don't think I don't think you've shown something that's extremely clever and interesting, but I don't see how that's a violation of relativity.
Then why was the velocity proportional at all? Why wasn't it just random and chaotic? It couldn't have been proportional randomly.
No, I'm not claiming it's random.
Okay, so it's co-moving.
Yeah. Well, it's not.
The segment is co-moving.
So the segment is not co-moving. One of the fiber optic loop is a loop that is rotational, right?
The straight section is moving in a straight line. It doesn't turn until it gets to the post. That whole middle part is a straight path.
Doesn't matter. It's part of a loop.
So you're saying that a straight line is rotating?
I'm saying that a straight line as part of a loop is rotating, yes.
Go read Einstein's paper where he says he talks about the equivalency between a linear path and a closed loop.
Okay. All right, but I mean, the fact is, it's a loop that is moving, and there's the device that's reading it is on the conveyor belt, and this is not this. If you do this without a loop, I'll start being impressed.
If I do this,
it's funny you mentioned that, because in the Wang paper, if you scroll down from the conveyor configuration, he does a parallelogram where the source and detector are stationary, and it's just the effective length at the top that's able to move. The side pieces cancel each other out, and the bottom segment is stationary. So when he's moving that top portion, again, the fringe is with respect to the effective length. So in that scenario where the detector, is an inertial observer that's stationary, the measurement is being made with respect to absolute space, because otherwise, relativity theory predicts that there will be no fringe.
I'll have to look at that. It's been a while since I've read that.
It's the same exact effect. It has the same exact data graph plot as the gyro on the conveyor belt.
I'm just telling you that the gyro on the conveyor belt doesn't it doesn't get you where you need to go. So maybe the parallel
it does.
Maybe
don't
the
understand
parallelogram.
It. I'm sorry that you're unable to comprehend it, Omni. Like, this is why I don't communicate with you very often, because I could spoon feed you your alphabet and you would start speaking in another language.
Okay, I got you.
I included the parallelogram configuration up at the top if you want to take a gander at it. If you found the thing at the jumbo on the first one, if you scroll over to the left one more, it's up there as well.
Yeah, inside he'll never be able to answer this question, and I challenge you to answer it, but I know you won't. Inside the optical fiber, because the fringe shift is happening inside the fiber. It's happening in the fiber. That's if it wasn't, then there wouldn't be a fringe shift at all.
All right.
With respect to what is that fringe shift taking place? You've got one point in the fiber and another point in the fiber, and between those 2 points, there's a fringe shift.
So the fringe shift happens when the light is recombined, right?
No, the fringe shift is happening continuously at any 2 points throughout that fiber.
So there's light going in one direction, there's light going in the other.
Yep.
And when the light is split and then recombined, yeah?
Yep, it travels in 2 paths.
That's right.
2 directions, rather.
Yes, correct. So the fringe shift is happening because one portion of the light is moving essentially a different distance.
Different distance with respect to what?
With respect to the in fiber optic gyros, it's with respect to the position of the gyro in free space.
The gyro in free space. Well, it looks like that gyro and that bottom half of that loop are moving at the same exact rate, so there's no relative motion between them, so there's no change in path length.
So that's where we disagree. That's where I disagree with you.
There's no change in path length, Omni. How does the path length on a closed loop change?
So it can change if the loop is moving, right? The effective distance can change if it's moving against. That's how fiber optic gyros work. Right?
Bingo, Omni. It can happen if the loop is moving, but see, the loop is the path of the light. So there's no relative motion between the light and the light path.
No, that's not true.
Hold on. There's no relative motion between the light and the light path because the loop itself is the path. So that means if motion is causing a fringe shift, then it has to be motion against something that's not the loop itself that's present in the loop.
No,
the absolute space.
No,
ether.
No.
You have it on me. It's right there in front of you. You said it.
Okay.
You did say space.
Well, it like fiber optic gyros actually do work. There's no question about that. So if you're moving a fiber optic gyro around, it's got 3 degrees of activity. It can check movement in each of those along each of those axes, and it works for that. There's no question.
How do you have a path length change inside of a closed loop, Omni? Only if something is dragging the light.
No.
Or if the light is being dragged against something.
No.
Because the loop is rotating through space.
The loop is rotating. Yes. Look at the.
Okay, so are you assigning imaginary vectors to points in empty space?
I am assigning a vector to the loop that is spinning around in a loop.
Spinning with respect to what?
Itself. It's spinning
with respect to itself. Thank you.
Welcome to the lab frame, brother.
I mean, like I said, this is understood as the Sagnac effect. Yes.
With respect to itself, absolute rotation. Yep. Because it doesn't invoke an external frame. It's not with respect to the lab. It's not with respect to the distant stars. It's not with respect to Mars. It's with respect to itself.
Yeah.
But relativity, that shouldn't produce a fringe shift, and it definitely shouldn't be a fringe shift directly proportional to the velocity with which it moves.
No, that if it's rotational.
What's it rotating against? Itself? How does that produce a fringe?
Because he hooked it up to a device on the conveyor belt.
Bro, this is the same thing as Sagnac's table. The emitter and detector are both on the rotating table. They're in the same rotating frame. There should be no fringe. It's the same thing. He's just taking it and showing that it happens not just in spin, but in a line.
That's the claim, right? But what
you still can't describe. You still can't explain the spin. All this is doing is showing that when the FOG is moving in a straight line, or when you flatten the loop out into a long straight segment, it works the exact same. And you can, instead of using the radial equation for the loop, you can select a straight linear segment and use the linear equation on the linear segment and get the same result. Now, if you can get the same result using a linear equation, that means it's not radial motion, brother, because then it wouldn't work. The two equations are not the same.
Nope, that's not true. You're wrong.
I can use two different equations and plug in the same numbers and get the same result?
That's not what I said.
That's the effect of what you said. That's the effect of it.
It's not.
So I can use the radial equation and the linear equation and get the same result with the same numbers?
You could ask me what I meant, or you could just try to play the yes and no game until,
Piezo, is this covariance?
Brother, ain't no such thing as covariance.
No variance right now.
What it is converting rotational to linear, momentum back and forth, which you can do because they are connected.
Which you can do because they are connected. Yeah, okay, what does that mean? How does that have any bearing on the effect?
It means
what is being connected to have any bearing on that cable? Doesn't matter. I mean, the cable is just to prove that they're moving the same. I mean, I could disconnect that cable if I could keep them moving the same without it.
So if I disconnect the cable, okay, then if I put the fiber optic gyro in my car and I go straight ahead, is it going to show me the fringe shift?
If the FOG is not moving uniformly, it's not in the same frame, and you are able to invoke a difference between frames. Mm-hmm. The entire point of it being connected, which you just admitted it's connected, thank you for that. Yeah, the whole point of it being connected is so that you can show that they're co-moving, which by the postulates of relativity, unless you're ready to abandon them, definitionally makes them part of the same frame. If they're part of the same frame, guess what, Omni?
Yeah, I know what you think. You think
the measurements are with respect to itself.
I know what you. I understand what you think, but
it's not what I think. It's just a fact, bro. I mean, are you going to fact it? Well, tell me what I was wrong about what I just said. Co-moving, same frame, right? Einstein, yes, no.
No. If one's rotating and one's not.
So now you're going against your own paradigm. You've abandoned Einstein.
If one's let me finish. If one's rotating and one's not, those are different kinds of motion.
So then, how do they produce the same result?
Because you're converting from one to another.
Converting where?
And the way that you're measuring your detector, they don't. So,
there's just one reading. You just have a reading, right? It's a number of fringes. That's the reading. You have a formula though, and you use the formula by plugging in the values that are known and see if it predicts the fringes that are measured.
Right. So what you're saying is that if you have this spinning loop without anything else connected to it, right? I have the spinning loop part of the Sagnac, of the Wang device.
Yep.
Okay. And I have it rotating, and then it's and then what? I will detect a fringe shift if it moves linear. Well, if it moves linearly, you still detect a fringe shift.
If Wang was able to, we're not able to do this. He would use it. I don't know if you ever watched the Magic School Bus as a kid. He would have had Miss Frizzle do her little Magic School Bus thing and shrink that FOG down and literally put it inside the optical fiber and put it inside it. But since you can't do that because we don't have magic,
right?
But he did the next best thing, which was just to put it right beside it, have it co-move with it so that it's still part of the same frame. It doesn't matter. Now, the point is that the effect is occurring inside the optical fiber alone.
Right.
And that means it's being measured with number one, it's being measured with respect to itself. But number two, he uses the linear equation. And since it produces, this is the crux, right? Since the linear equation correctly predicts the measured fringe shift in this linear segment, and the radial equation correctly produces the fringe shift in the radial segment, like around the little wheels, and they both yield the same result, that means that the linear motion and the radial motion are equivalent. The way you would prove that they're not equivalent is that they would produce different results. The fact they produce the same result means they're equivalent.
It means you can translate. This is the translational velocity. This is like the Earth's equator is turning at 1,000 miles an hour, and people are like, "Oh my God, 1,000 miles an hour!" But it's that's actually super slow.
Yeah, translation is linear motion. Okay,
right. So you can translate back and forth between those.
Bro, did you say 1,000 miles per hour is super slow?
Yeah.
So wait!
I want to clear this up with Sacred. So Sacred.
No, don't subject change.
No. I know, but
No. Focus. My bad. I didn't mean to interject. I just thought that was hilarious. Go ahead. Focus.
the segment is linear right there in the loop, the straight part. Okay. This shows that linear motion is being measured by a Sagnac device.
No, it's not. So
you said earlier it was linear. You just said it was translation. You've said it twice now, bro. How are you going to now change your word and say it's not?
So I'm telling you what's going on, but I'm going to.
You're literally flip flopping all over the place, dog. You don't know which side to pick. You're stuck.
Well, listen, my puppy.
I'm not your puppy, dog.
Well, you're calling me dog? Okay. So, listen. So, Sacred. The reason why 1,000 miles an hour is...
No. I don't care about your interpretation of how fast 1,000 miles per hour. I just want to make sure I heard that clearly. Address piezo and why you jumping back and forth between translation and motion or not. Go ahead, bro. Don't redirect over here, piezo. Right on your ass, bro.
Well, you shouldn't have laughed then.
It was funny.
We can come back to it. We can come back to it later. Stay on task. Stay on task. We can come back to it later.
We're not going to get anywhere with this.
All right. Well, then your time's up. Then you forfeit your mic if you want to discontinue the conversation.
All right. That's fine. So the reason why 1,000 miles an hour is slow is it goes around.
You is not gonna do that, bro. Address piezo. Address piezo. Damn, piezo, you got him running out of here.
Straight bounce. He was looking for that exit hard, dog. I know Wang. Oh, you can't talk to me. You just got talked to Wang about, dog, and didn't have a damn clue about nothing.
Bro, and Sacred, I know you don't know that much. Like, Omni been in here a few times the last couple weeks, but he would, like, before that, he never really came through. I know him from Earth and Awakenings, bro. This is why I don't engage with him, because what ends up happening, bro, is we have to go through this super long, drawn-out conversation at which every turn becomes an inefficiency that wastes so much time just to make a simple point. But thank you for the moderation, because, that actually forced him to, like, stick to the topic, right? And at the end, you saw what he tried to do. He tried to turn to, oh, what about this Earth thing? No, bro. No. What did you just say? Right? So thank you for holding him to it. But that's what always happens. This is why I don't engage with him, because it's the same pattern of behavior every time that something like this comes up. But I'm glad that we got that out, because everybody got to hear it, right? I mean, y'all heard the flip-flop happening like 2, if not, it might have been 3. I'm gonna give him the benefit of the doubt and say 2, because those are the 2 I could put my fingers on. Swapping back and forth, saying it was translation, it was linear, but then when he realized, oh no, I just broke my paradigm, then he immediately was like, oh no, it's not. Yes, it is. No, it's not. You don't have anywhere to go. Bro, Sagnac, they haven't been able to explain Sagnac for over 100 years. It's been like 113 years and there's still no answer for it. Sagnac demonstrated, he literally did this experiment back in 1911, 1912, specifically to disprove relativity. In Einstein's original paper, it talks about how a closed loop would basically be the same as like a geodesic for the Earth, like a linear path, like a giant closed loop. Because if you make the loop big enough, it's effectively linear, because any part of it's going to be a straight line.
Yeah, up in the jumbo, I put Einstein's 1905 paper, 2 quotes from it, right? So laying out the basic premise of how he's not going to assign velocity vectors to space where electromagnetic processes once took place, and then where his equations apply in the rotating frame, because like Piezo was saying, you can extend it to infinity and it's basically linear. And on top of that, there's a bunch of different other ways for relativity to account for uniform translatory or uniform rotation. So, it definitely applies for the relativist. Otherwise, they, just ask them about Thomas precession, right? So they would have to give that up, even though that's part of it's canonized lore now. But yeah, when you get into the 2 configurations of the interferometer, right, they're both deadly, right? So the first configuration is the co-moving FOG with the optical, or with the loop. So relativity predicts that there's no relative motion between the two. So if you're an inertial observer, right, the way that they say that the Earth and Sun are moving, the relativity predicts that there's no fringe pattern, right? That's why Michelson-Morley, they say, produced a null. But when you look into the measurements, obviously they measured a velocity, just not one that was high enough for them to confirm heliocentrism. Actually, a velocity that would entirely refute it. And then the second configuration Wang did, where it's just the top linear portion that's moving with respect to a stationary detector. Well, relativity predicts that an inertial observer will measure c as c, meaning that the speed of light will not be affected by the translational motion of the top portion of the interferometer. And the fact that it measured it proportional is a direct refutation to the first and second postulates. Right? It shows which inertial frames, that they're not all equally valid, and that the speed of light is not measured as c in an inertial frame.
And we're looking at a first order measurement. There's no second order calculation here at all.
Super pivotal to the, yeah, exactly, dude. So on that note, right, even if relativity did predict a fringe, the fringe that it would predict would be a function of the square of the velocity over c squared, which is much, 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 much smaller than what's actually measured. So it has no explanatory power over measurements of velocity regarding an interferometer. The measurements are first order, and the velocity components are also first order, meaning that the velocity that was measured by the interferometer was caused by that velocity. There's no, it's not like it was moving faster and there was a contraction and it's just a ratio of the square of that. No, it's directly proportional to what it is.
Linear c plus v.
One
Sir.
for one linear sum, linear velocity addition. But I love the fact that like people listen to these higher. If you're listening right now, right, and you're a person who's not super well acquainted with Einstein, don't get intimidated by it. Don't be like, oh my gosh, it's such this mystical, high level, mathematical, physical, scientific stuff that's so hard to understand. No, bro. If you can keep up with just listening, and this was kind of an intense conversation, but if you can just keep up with the main points, right? And they try to keep the main points from getting out. They don't like the audience to hear the main points. But if you can just keep up with the main points, most people, you don't have to be super smart. Average people can understand this if they'll just pay attention, have their attention span focused long enough to hear what the points are, and use basic logic. You can comprehend these things. You don't have to be a rocket scientist, as the saying goes. But yeah, I mean, if Jimmy's standing on the ground and Jill's sitting in a truck, and in the truck Jill doesn't feel like she's moving, and on the ground Jimmy doesn't feel like he's moving, but if the truck's driving 40 miles an hour, they get a 40 mile an hour difference between them, right? That's basic Galilean relativity. But if they're both sitting in the truck, it don't matter how fast the truck's moving. There's no relative motion between them. So you wouldn't predict any difference in what they feel. That's the same thing here. You wouldn't predict any difference in what the two sides of the loop feel, or two different parts in the loop feel, two different directions, because it's all in the same frame. But when they measure it, there's a fringe shift, and that fringe shift is directly proportional to how fast they're moving. So it's like taking the windshield off the truck, right? Now that I take the windshield off, there's a third element involved. It's the wind. When the wind wasn't there, I couldn't tell how fast I was moving. But when the wind's there, now I can measure myself against the wind. The wind in this analogy is the ether in the loop. In the absolute lab frame, right, there's ether. And when this loop's rotating, it's rotating against the ether. And that ether that it's rotating against is allowing it to create a difference, right, in the velocity. It's plus or minus v against the ether. So that's what's able to cause this physical effect, even though they're co-moving in the same frame. I hope y'all can understand the truck.
That was a great one. All right, suppose we have two cyborgs playing ping pong. Right?
Yo, Boston's got his hand up for a minute. What's up, man? Sorry,
chat.
no, it's not my space, my bro. I want to hear what Boston has to say.
He's still awake? What up?
Oh no, you're good. I mean, I've been trying to go to bed for like 3 hours, but I just stayed tuned in. And Piezo, what a display! I mean, I was feeling like I was watching 5D chess taking place. The patience that you were showing, eloquent speech. Gosh, man, just laying it out. And then at the very end, when you encouraged everyone in the space to just be patient with themselves as they're playing catch up to these deeper level, thinking and sciences. Because, I mean, I've told many of y'all, I didn't like school. I felt like it was boring. I didn't like the way they taught, memorization, regurgitation. Oh, you didn't make the grade. You got a B, you got a C, it affecting your psyche, it affecting your self-esteem grades. What does it even mean to make the grade? By rogue memorization, and then just the bell, which is buzz out, get back to class, break up your conversations. Now it's lunchtime, and school was strange for me. I always wanted just to be playing outside, making friends. Relationship was always way more important than the way the school, was laid out. So, I mean, 2 years ago when I was told that outer space as taught is not reality, you can't go there. There isn't light years to travel. It's an enclosed system. I mean, I honestly, it was like, what? That's insane. What do you mean? But the thing is, as a father and as a husband, I hungered for truth. I wanted to know what the truth was about creation. And I don't know that I have the answers of what creation is, but I know what it's not. And it's not a spinning, wobbling space pair going around the sun. That's just ridiculous at this point in my journey of truth and awakening. And the heliocentric theory is just a theory, and it's taught to many. It's taught to millions today, but it's not the truth. So yeah, I just really, really appreciate how far you and Shane and Alan, and now I've gotten to know Sacred and Proud and Flat Earth Fridays. So many people are learning more of the deeper concepts and these truths daily, and there's a fire to it. Like, it's almost like if somebody didn't even like chess because it looked complicated or it was just a weird game, but they start getting into it and they start understanding what like grandmaster means, and then they watch someone playing and it just gives them the adrenaline and the thrill. Like, so I'm not thrilled because you demolished anybody in some sort of debate. I'm thrilled to hear truth spoken, and what you guys are doing is you're mining it. You're reading papers. You're looking at what the great minds spoke about, and that stuff got swept under a rug or ignored, or it got labeled as quackery, or even Tesla, like, oh no, 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 don't even look at his stuff, or don't even think about that. No, no, there's no ether. No, of course we're moving. But we're in a time now where people like you, Piezo, and everyone that's hungry for truth, hungry to share it, bold enough to think for themselves and dig. Um, we're uniting, and I love it. So anyway, I had to come on and just say I'm proud of you, and then you pushing people towards the Creator. You having a multifaceted approach to finding truth and sharing it, and sharing your own personal testimony. It just really speaks to me, brother. So much love to you all. I have to go to sleep because I got a big day with the kids tomorrow. Got soccer, got a birthday party, all that kind of stuff. But this has been very exciting, and I was really happy to stay up late. And then to let you know, Dave is about 4 people away from getting 200,000.
Thanks, Boston, bro. Much love. God bless you, man. Keep the faith.
And thanks, Sacred. Thanks for what you do, man. You put in the hours. Like, I did 5 hours of watching the hands and trying to keep them in order and trying to be fair and moderate a little bit. I can't imagine 111 episodes going as long as y'all go. You really are cyborgs. Like, I realized that tonight.
Hey, well, I wanted to talk to you about that, your first experience, because a lot of people don't understand like what goes into hosting. People just think that you up here just like miking it up and stuff like that, but it's a lot more that you got to pay attention to, making sure that the space runs smoothly for your listeners. So I'm glad that I guess what your spaces cherry was pop like as a host.
Yeah, dude.
But that is interesting going through that like learning process. Like, okay, how does this work? Okay, who's next? Okay, who's DMing me? Who's mentioning me? Okay, is everything functioning properly? It's a lot that goes on, man. But it was a great space earlier. Shout out to y'all.
Hey, thanks for that. Yeah, it was trial by fire. Dave was like, "Hey, how hard can it be? First space, let's go." And I was trying to tell him about the like refreshing the space with the extra tab because it might get all wonky. He's like, "Oh wait, what do I got to do?" And we got him going. But yeah, like I was trying to give out apps to people with iPhones. Like I would have to go off to the side and get their email and shoot them, a gift for the iPhone in the US. It couldn't be, overseas or it wouldn't work. And then I had to figure out if they had an Android, and they were emailing me like crazy. So I was like in the NX trying to like see whose hands next, keeping a list, jump into my email. And then you could look back and you like allowed 3 people in and you don't know if they raised their hand and in what order. So it got wild, but I'm a perfectionist. I like to do things right. And when Dave was like, "Hey, can you help me co-host?" I was like, "Oh man, snap! I'll give it a try." And you're kind of nervous, like, "Oh, how's this going to go? Am I going to do well?" But really, man, I feel like we're all just brothers and sisters in the truth. And mistakes will be made. There'll be some stumbles, but if we're all looking for the truth every single time we look up, we're going to keep going in the right direction. So yeah, thanks for the encouragement there, bro. And yeah, much love. It was fun.
For sure. Hey, I got one challenge for you, JT. At the birthday party, you have to reach out to one parent and ask them how gravity is affecting that helium balloon, and then you got to report back to us.
Oh man,
and let us know what response you get. At least one parent.
That's going to be easy, man. I love talking flat earth. My wife's always like, "Oh shoot, are you going to bring it up again?" And I've got her flat smacking people. She's like straight talking about the enclosed system and everything. So yeah, I'll report back. It's not scary, man. Just bring it up. People in the real world, out in the reality, they don't act like these anti-flat earthers. If you bring up how some of this works or why does it work this way, and you bring in some physics, or you bring in the stationary nature of our realm, they generally will listen. And I've enjoyed talking about flat earth. So yeah, I'll report back.
That's a good point too. You're right. There really isn't that many hostile anti-flat earthers in real life. Not that I have encountered. Like that's a really good point. They're only on the internet.
Oh, hey, let me tell you one more story before I go. So I seen this guy with a wild shirt on, and he had like colors, like real wild outfit on. And I was like, "Oh man, dope. This guy's going to be easy to talk to about flat earth." And I was like, and I always start with the compliment. I'm like, "Hey man, I like your style. That's pretty cool. Your get up. That's great." And then they're like, "Oh yeah, thanks." They're all happy because you're talking about their outfit or something. And I say something like, "You're probably open to, how crazy the world is." And they're like, "Oh yeah, everything's crazy." And I'll say, "It seems like everything's inverted, man. It's like everything's toxic in the food." You just start with baby stuff, and they're like, "Yeah, man, it is. Everything seems to be poisonous." And then you say something like, and "I think they lied to us about us being on a spinning water ball." And they're like, "Huh? What do you mean?" I said, "Yeah, man, I think we live on a stationary topographical plane that's enclosed. Do you want to hear about it?" And they're like, "It may go that way, but this one time, this guy that I had pinned on being easy to talk to, when I brought flat Earth up, he was fine with all the deceptions, any of this other stuff. He seemed like a conspiracy theorist. But when I brought flat Earth up, he just cut and ran. Like he looked at me funny and then just walked off pissed. That's how he had to cope with it. So don't think you can plan it or pin anybody, because another time I had already told most of y'all this. When I went to Boston last time to race, I was bringing it up to a whole bunch of people, and I'd say if it was 10 people, 4 of them were already flat earthers, and they were excited that I had brought it up, and they were talking to me about all this cool stuff that they were finding. So you bring it up, take a chance. They might look at you like you're stupid. You're not. You have the truth, and you'll be surprised when you find people that are already awake to it. So anyway.
That's a fact. And sometimes you'll get somebody like, "Oh, you flat earth too?" Like they'll be super excited, just waiting for somebody to bring it up, but they probably don't have the confidence because afraid of getting ridiculed or something like that. But you never know; it can go either way. But yeah, don't just like what it says, truth doesn't fear investigation. So we should be able to go ahead and speak our minds and look into all these different things and making sure the thing that they're giving us is actually the truth and not some fairy tale. So shout out to Run Boston Beer. Hey, go subscribe to him on YouTube. He got a bunch of dope clips. I think he did his first live the other day, which was awesome. I missed it, but looking forward to catching the next one, bro. Go ahead, chat.
Yeah, what's up, guys? I just wanted to say that you handled that so well, Piezo. Like that was like you distilled juice out of a rock. Like I don't know how you did it. Like it was just so clear to the audience like what was happening. Like he was using his tactics, he was squirming, and then you brought up the 1,000 miles per hour, and you could just tell he was trying to escape the conversation so bad. He was just stuck in the corner. And
bro,
then
if I knew he was looking
away.
for an exit that bad, I would have never said nothing.
No, it was okay. It actually worked out perfect because, he had exhausted his bullshit. And he, now it's just clear that he just wanted to run away. Like it's just very clear. And one last thing I wanted to say, and then I'll just get out of here because you guys do better than me anyway. The first time I spoke to Omni before, we didn't know each other really or anything. It was a private setting. He told me specifically he spent his career in the military performing counterintelligence. So keep that in mind. Like if it seems like you're wasting your time with people, don't waste your time because there's people out there who aren't counterintelligence for the military, and they're probably better to talk to.
Damn, that context is crucial.
Hey man, we have the truth behind us, right? So it's the truth doesn't really need to be defended, it just needs to be let out. You just got to know how to let it out, man. You just got to be able to explain it, and it fights for itself. But I do appreciate it, Riggs.
I think a lot of the globe Earth, a lot of the anti-flat earthers' biggest fear is that somebody who they deem, on their side with credentials, a part of the globe Earth conversation, will see validity in what we talk about and some of the things you guys present, and that'll show like, that maybe there's some truth to what they're talking about. So I think we're on the right track, finding these common grounds with the credentialed people we share this land with. That makes sense. And who knows, maybe one day something will catch Bennett and it'll just be like that one thing he needed.
Honestly, I'm fine with him like holding the views he has right now because he's 100% useful to the movement of truth by spreading geocentrism. I've said this before in this space. I don't even obviously I believe that we live on a topographical plane, but I don't even believe that part of it is like the first step of the most importance. I think that the geocentrism thing is more important. They're not like mutually exclusive. Like you could have technically one or the other without both. And it's the uniqueness of our position and our centrality, right, that makes us special. That's the important part. The important part is that people know that we are special. Now, the easiest, quickest way to do that is obviously, hey, we're living on a giant topographical plane inside of a closed system with like a firmament over our head, and we're just stuck in a giant fishbowl or whatever. Like, duh, obviously, like that's going to destroy any paradigm you've been taught. But it's equally going to destroy the mainstream paradigm if they find out that the Earth's the center of the universe and everything's moving around us and we're not moving. Like, both of those destroy the paradigm. And one of those is much easier to accept in the beginning than the other. I'm here, because I think that it's important to share the truth and win souls, to wake people up to the truth, point them back to the Creator, to the Lord, to God, right? So that they can see the truth and know the truth and find Jesus and be saved. This is just one of many methods. I do it in other ways in different parts of my life. This aspect of my life, this is the science part, right? Different strokes for different folks, as they say. But Bennett is doing great work in the geocentrism battle, and that by itself, you could wake people up to the lies without ever changing the shape, as long as they know that they're not moving. So if it's gonna ever create a rift or rub somebody the wrong way, I would leave it alone, because it's plenty plenty beneficial enough, in my opinion, that he is such a staunch defender of geocentrism, and he's been a wealth of knowledge and wisdom to our community. Little does everyone know, like, just how much of a contribution he's had, not just actively but passively, just research that he's done and information that he's gleaned that we become aware of because of the work he's done, and that helped our efforts to point us in the right direction. Like, that man has done a lot of work in his years, and it's helped us without us ever having spoken to him. So,
and his research is in their paradigm. So it's like, who better to start refuting it than somebody who literally got their PhD in the same field? Yeah, Ben is a gem, man. I'm not gonna lie. I'm just more like, obviously, like the people that are sitting on the fence, maybe those who are hearing this conversation for the first time. I kind of say this often, but those are the target audience of, we want people to hear the back and forth. Obviously, the anti-flat earthers they're not gonna update their position. They stuck in their ways. It is what it is. I'm just more like, I shouldn't be shocked, but I am. When I've been like interacting with some of these other anti-flat earth credentials, just like Proud was saying, I'm just expecting them to, okay, cool, we got some real physics, we got some credentials here. I thought they would be motivated to address the point. After that whole time that they've been saying, like, oh, you guys can't talk to me about physics. Oh, you guys don't have this. Oh, you guys don't have that. Why don't you just go publish the paper? Then I'll read this and that. Now you literally get everything that you've been asking for, and not one thing was addressed. It really bothers me, man. I'm not gonna lie. Like, I'm sorry. That really, really bothers me. I don't think none of y'all credential guys that be over there toxic in dementias should be talking crazy no more after this. Like, literally, I don't think y'all have an excuse. I don't think y'all have a argument outside of the topic at hand. If you're not going to talk about the physics when you got somebody in front of you that's well-versed in it, just like you've been looking for, and you still obfuscating, what do that mean, bro? What, like, your position must be weak as hell. That don't make no sense. So it was interesting to hear Bennett kind of react to some of those tweets. I didn't read all of them because he had to get up out of here. But I'm telling you, I was going to take my time to do some of them tweets. Y'all, I ain't going to hold you.
I believe there's a percentage of them that physically can't talk about it. We've discussed that they're under certain, like, they have certain barriers preventing them to have certain conversations. But yeah, at one point we were all asked, like, do we think that they're purposely deceitful, or do we think that they're just ignorant to it, or, living in their obfuscation? Like, what is the underlying reason for why some of them haven't snapped out of it or tried to address it? And we personally seen it happen in real time, where we've presented a PhD with a paper that contradicts his theory. He didn't like one thing in that paper, disregarded it, and then tried to mock it. And it's like this is science. You shouldn't have a opinion, like an emotional opinion to it. You should be able to look at it, have your contradictions, and then present that, especially if you claiming to be a PhD. So we have an outlook on science and how people behave within the scientific community, because it's things that we've seen while engaging in this conversation. All of a sudden, engaging in this conversation takes people's tenures and throws it out the window. Like, you spent 60 years in school to act a fool about a speed of light paper, man. Come on now.
Hey, you know what? Shout out to Paul Marmé. In that paper, he was actually trying to derive everything as a function of the gamma factor. So, like, even if you don't agree with his analysis on the constancy of C, he was still trying to use everything as like an E equals mc squared function where, things would change proportional to their velocity. And it's like, dude tried his best, bro, and he still shot it down just because, like, it overall didn't agree. But yeah, it's crazy, dude.
To what Proud said, though, by the way, Proud, this is, I told Alan this the other day. This is the way I think of it. Like, we're talking about scientists, like, not being able to not comprehend, but to deal with science. Like, they're not able to deal with it. They become emotional and, biased. Every scientist is a human being first and foremost, right? We can't remove the human element from these conversations of how it affects a person. And when it comes to the schools of thought, as they are called, the schools of thought, there's a hierarchy, right? There's like a pillar. There's a hierarchy, and you can start at the top and go to the bottom, or work your way up from the bottom to get to the top. Either way, but you've got the sciences, right? You get your mathematics and your chemistry and your biology, and then above those sciences, then you have physics, right? Physics is like a gym, okay? It helps explain the world we live in. But actually, there's a science that in this hierarchy, right, actually gets put above physics in human beings' minds. A lot of them, whether consciously or subconsciously, and that's astronomy. Now, there's a reason that astronomy is considered to be like the king of sciences. It's right above physics. That's because astronomy is the next closest thing to philosophy. Astronomy is the thing that has the direct connection to your cosmology. The cosmology, your framework of the type of world that you live in, right? The type of universe that you live in. Your cosmology would be like, a geocentric globe or a heliocentric globe or a geocentric topographical plane. Like that's your cosmology. So astronomy is the most intimately connected to that. And cosmology, of course, is what, is directly a part of your philosophy. Now, philosophy is at the very top of the schools of thought, or so it's said to be. But actually, and this is, from Bennett, because I had philosophy at the top, but I heard Bennett say this and he explained it, and we had some overlap in some of this, but he actually said, and it made sense, I agree with him on this, that just above philosophy, the actual peak, like the capstone on the pillar, so to speak, is theology, right? Theology is actually at the very, very, very top. Your theology is the thing that is the most deterministic of your entire worldview, your entire psyche, everything about you, of everything you believe in is based right off of your theology. Now, people who are atheists or naturalists who reject theology, right, then they, of course, go to the next step underneath it, which is philosophy, right? And if your philosophy is this godless, naturalistic world of emptiness and hedonism and meaninglessness, and Big Bang, back, rocks to monkeys to people evolution, then, you better have a cosmology that supports it. And in order to do that, you got to learn some astronomy. And so it all goes down from there. That's why in that movie, The Principle, which Dr. Bennett was in, they talk about the Copernican principle, which I know you guys have heard it a million times, but the principle of Copernicus was that the Earth does not occupy a special or a unique position in the universe. And through that lens, through that principle, that's the philosophy, right? That's the peak of their pillar, because they reject the capstone, which is theology. Through that lens, the Copernican principle, they thereby interpret the astronomy, and then they thereby interpret the physics, and then they thereby interpret, the biology, the chemistry, all of it, right? But it all stems from the philosophical premise that they hold. So that's how they interpret everything, is through philosophy. So when you talk to a PhD, circling back, when you talk to a scientist, when you talk to these people, if they are part of that godless, hedonistic, emptiness, meaninglessness framework, and they reject all of those things, and they reject goodness and reject truth and reject spirituality and reject Yahweh, they reject the Creator, then they are going to have a vested interest and also just a mental block, a spiritual veil over their eyes that's going to cause them to fight tooth and nail against any truth that you have to show them that's going to flip their cosmology and thereby their philosophy. It's not about the science. See, if it didn't have a consequence, they'd be indifferent to it. It'd be like, oh, the speed of light's not constant. That's cool. That's fun. That's interesting. Word. Cool. Thanks for showing it to me, right? But it's the implications that brings that they're not able to accept, and that is the reason they fight you and reject it all.
Yo, thank you for saying that, Piezo, because that's what I really want the audience to understand. The reason why we having this like in-depth kind of techie conversation is because the implications of what happens if everything that they're saying is wrong. Like if it's literally the opposite of what they're saying, they can't have their globe Earth in motion. They can't have their orbits. They can't have their space. None of that works. So this is why, like, because we're saying, like, those who not really attached to it, be like, okay, well, cool, that's interesting. Let me go look into this. And those who's completely attached to this framework that's been given to them and misrepresented, bro, it shatters their whole reality. And I don't know if they base their whole life or personality off of it, which is why they're so emotionally attached to it. I don't know. But it's very strange behavior when you're supposed to be talking about science and supposed to be devoid of emotion, devoid of attachment, and we're presented with new evidence, new information. You're supposed to update your position, not fight for a dying model, if they even have one. Would you even call it that?
I think they're gonna find a way to incorporate it into their model and make it work under the name of something else.
Imagine your belief system couldn't explain a spinning bucket full of water. Then now we're at, and then now we're so far removed from that, we're at interferometry, right? Where it's like the light is showing the difference instead of the water. And they're like, well, you know what they say, man, space and time, they're just intertwined. What? How, let's back it up to the bucket. Can you imagine the gall on someone to say that they can't explain a spinning bucket and that falls under a different theory? But this other theory that they super believe into, it like definitely explains everything that's not a rotating bucket full of water. Get out of here.
Dude, I love that. Oh my gosh, that was so beautifully put, dude. Man.
This is what I'm saying. Like, I mean, I tagged like 2 or 3 PhDs about a bucket, and none of them wanted to talk about it.
Bro, that guy,
none of them.
That guy Andre Assis and Alexander Unzicker, right? The big physics lads. Oh, Ma's principle, Ma. Dude, Bennett emailed them the same questions. Aziz didn't even reply, and Unzicker, I forget what he said, but he gave like a haphazard reply and then he never followed up. They know it's retarded. The Earth is obviously stationary. That's the lab frame. That's what it's with respect to. To say that the rotating bucket is with respect to the stars, like, dude, that's insane.
Hap, if you didn't fall asleep, Hap, you should come chat about this. I mean, I feel like you've heard 90% of Bennett's presentation. You've been in here listening. And you claim you didn't want to have to wait for a mic.
Wait, Hap been in here this whole time?
It's PhD night, bro. You get priority. So I don't know what your aversion to, talking about it would have been.
Who's in here?
An astrophysicist.
Boy, Sleepy McSleeperson.
An astrophysicist has been engaged in listening. I don't think he's been tweeting, so that's pretty good, but I hear crickets.
What's his name? Where is he in the list?
Hap. I think you guys have talked to him. If not on here, then on Discord. Somebody talked to him. Hap Bro.
He pulled up to School in the Globers one time. We threw him over there. Earth Awakenings.
Oh, no way. I don't.
Yeah, that was a time I was trying to grab the mic and my mic was all messed up. Y'all couldn't hear me. It was a while ago. But I'm mad that he been in here this whole time to say PhD night. Everybody mentions too, and he just stood down there this whole time, bro. Don't tweet at me no more.
Have to wait for a mic, so I'm just letting him know that that's not a problem. On PhD night, where we're highlighting the PhDs.
Man, I can't find him in the list. You said HOP like HOP?
No, it's HAP for Hap, and then I forget the other part of his name, but yeah.
HAPHRO. Hapro, something like that.
Yeah, I must be bugged. I don't see that guy.
We even had some PhDs from other platforms lurking. Better not be anonymous, man.
Those anonymous PhDers, bro. Imagine you paid a whole bunch of money for your PhD and you don't use it to dunk on flat earthers on the internet on a Friday.
Imagine.
Like, what's the point of even
what's
having
the point?
Dude? You just got it on your wall to impress people when they come over. Like, nobody gives a shit, bro. Come tell us about the bucket, lads.
Did you see Franco's reply to Sacred about Bennett's bucket?
Yeah, dude, full dog shit. He was like, "Oh, that
He's a-
falls under general relativity." Yeah, dude, you need a general theory to fucking explain a rotating bucket full of water. You're fucking insane.
You know, he before that he said, "I also prefer not to discuss with people who sport a death instrument as a profile picture."
Oh,
So
See,
dude.
I didn't want to read everything. I'm telling you, man, I was going to drag it out, but I'm like, I don't know, Bennett really here for all of that. But
because
I
Bennett's
really wanted him
picture,
to get like that's the type like if you're not going to get a reply, this is the type of reply you probably going to get, which is why they probably don't reply because this is crazy. Like, why would you even? Bro.
So soft. And then if you look at Bennett's picture, the truth is in the noose. It's not like he's saying, "Oh, we should get together and go hang somebody." It's a statement about the truth. It's not a debt like, dude, Frank. Fucking
yeah,
coward, dude. That's when you know you've reached maximum cowardice. When you look at someone's avatar and you're like, "I will not engage because of the death instrument. He may hurt someone." Bro, he's a 94-year-old man that has a disagreement about the bucket. And you're gonna not engage
Disagreement.
because
Did you say
you're
94?
you're not gonna engage because of his fucking avatar, dude. Get the like
Did you say 94, dog?
he's like 93 or 94, yeah.
No way. He's in his 90s?
Yeah, you didn't know that?
No,
Bro, he's
way.
sharp, man. I'm telling you, he's sharp.
He's in his
Crazy.
90s? I didn't know that. I never would have guessed that, dude.
Yeah.
What?
That's why it's crazy. That's why I like to pop my shit. I'm like, yo, he got the longest tenure out of all of y'all. Now y'all can't say nothing.
Bro,
Pull
this man
up.
was-
He was doing physics while we weren't even born yet, dog.
This man was born in like 1930, dog. What? 1931, something like that? Are you kidding me? Bro.
We were still etherically displaced before.
Dude, when he got his PhD in relativity, he had the OG relativity lads back in the
Dude, he got the first one, bro.
the first one.
They got the vanilla version. He didn't get the patch. Dang. Well.
Context, man. It's crazy.
Yeah. Just let me know what I need to change my avatar to so we can discuss a bucket full of water and I'll help you out.
Bro, he said, imagine the gall when you can't explain why water in a bucket curves and you get so far gone that you now we're dealing with laser beams and light. And you're like, oh yeah, it's just space and time are warping, bro, Is like what you gotta actually just step back for a minute sometimes and realize just how crazy all of this actually is that they're teaching. It's ludicrous, bro.
Is that a headband around your avatar, Alan? I'm calling Peter. I'm not debating nothing
yeah,
about
dude.
motion.
That's a strangle instrument, dog. You know what headbands could be used for? Murdering. Can't engage.
Who actually says people who sport a death instrument as a pro? What kind of a statement? What kind of a sentence is that?
Someone suffering from extreme cowardice.
It's just the unnecessary stuff, man. And I get it. Like, we have like somewhat of a history, I guess, with some of these guys that's in the mentions. But it don't have nothing to do with that, bro. Like at a certain point, when you going to treat science like it's science? If you're going to hold it to a certain standard, like keep that same energy when it's right in front of you.
Just remember, he's one of those individuals who holds so tightly, like he had like an identity component based on his like credentials and his degree and stuff like that. Like, he swings it around every time he comes in here and people try to talk about it, talk with him about stuff, and he brings it up. And it's like, he's one of those people who's like, I have a PhD, if you better go back to school before you talk to me. You can't invoke stuff if you don't go, that kind of guy. So if you got Bennett in here, this man's like 90 something years old, been in the academic world for like 70 years, who's, done all kinds of work and been in documentaries and published papers and etc. I can see why Franco might not want to talk to him because he can't pull the PhD game, anymore with Bennett.
Exactly. That argument is obsolete. Literally. Neutralized. Which is what I said to him.
So, do you guys think the PhDs have a right to take it personal since it's wrapped up in their job description? It's in their name.
It makes it so much worse, Proud. It makes it so much worse because they are like, it's bad enough for people who are just, high school educated, who are indoctrinated through public school. Imagine you went and took like $300,000 in debt and went to school for like 12 more years and developed your entire living. And, the thing that now sets you apart as an adult in your life upon a framework, and now someone's telling you that framework's wrong, right? Like, the level of like attachment that you have is so much more deeply ingrained than the average person. It's way worse with PhDs and people that are high up in academia and involved in it.
Don't you think that, I mean, is Bennett just the anomaly then? Because he has his PhD in their paradigm, in relativity, right? Even when it comes to like this discussion, like I said, he did have critiques saying, hey, what I hear him say with the flat earth, globe earth debate, we use some of these different measurements and demonstrations, experiments to our advantage. He said, as you dive deep into like the physics debate, you're going to have to, learn a little bit more, start sharpening your tools, or basically, I'm paraphrasing, but he's encouraging the conversation. He's encouraging, once you continue to have this conversation, continue to read these papers, continue to immerse yourself in the sciences, it'll be more fruitful. You'll get more value out of it. You'll be able to articulate yourself more. He's not like trying to get people away from the conversation like some of these other guys. Like, oh, you guys shouldn't be discussing this. It's like, no, continue to discuss it. Continue to have that conversation. And it's just two PhDs with completely different approaches. That's why I was really trying to highlight that. It's encouraging versus discouraging. And I see my man Matthew up here. Before we get to Matt, let's slide over to Gala. Galatrax, what up?
Is that Galatrax with his orb in hand?
Yeah, hey, I've been in this. I was in the Dave space at 11, and then I had to drive home. But I've been cleaning for like 5 hours, just listening in. And I just want to say, Piezo, man, you've been sharp as a tack lately. You smacked McToon on EA. You smacked Omnivore. I mean, just pinpoint accuracy was the first thing I wanted to say. You guys have the patience and the rigidity of like mountains. I mean, Sacred being able to do this for what, 8, 10, 13, 14 hours in a row. That takes a lot. And Piezo dealing with these people, it's probably really hard. On the topic of highly educated people, I don't think they're all necessarily very bright. A lot of times it's maybe they have discipline and they can study, a certain subject for a long time. But, I notice they tend to be very civilly obedient, where it's like, they're incentivized to be. But I know some doctors, I know some nurses, and they could be experts at their field, but it doesn't mean that they're, particularly bright, or they definitely not innovative, these ones that I know. And they don't consider themselves bright or innovative. Like, if you talk to them, if you talk to doctors, they're like, yeah, I know my stuff, but they feel like there's always someone better than them. I had a question for Sacred. If you were to double dog dare someone something and you don't do it, does that mean you're chicken shit?
I mean, a double dog.
Dude, I think there was a
double dog
triple
dare.
dog involved, or was it just a double?
Right.
Yeah. What if it was a triple dog dare? Does that mean they're scared?
Was it
I mean,
a DAWG dog?
It was a DOG dare dog double.
How
It was
do
a
you know,
dog.
Alan?
It was a dog squared and a dog cubed.
the dog cubed.
Yep.
Oh, just to be fair, Hap said he is not scared. He's not running from the triple dog there. He is having mic issues.
Oh no, it was Alan. I triple dog dared him today.
So, from my reference frame, I read, "I dare you to give a speech on Galatrax," and then everything after that didn't read. And then I saw double dog dare, and then I saw the emote for the triple dog. But yeah, request denied.
Thank you, by the way, Galatrax. I appreciate it, bro. That's not for gain or notoriety though.
Yeah, and humble too, man. And sharp as attack and humble too.
Yeah, that's a fact, man. I remember when Alan first was telling me about Piezo. They were looking over something like with some papers or whatever the case is, and I had no idea that Piezo was so articulate, well versed, and just again another instance of just making that connection and finding a new speaker to come like drop some serious sauce. And it's just so dope to be able to get these things all in one place, man.
Dude.
Piezo, bro.
Bro, I was in the sewers spelunking, right? As one does. And I hear the sound of someone being super reasonable and making coherent arguments. I swim over there with my scuba gear in the sewers. And I find Piezo breaking down Battle of the Beams in a room full of sewage. And none of them had anything to say. And he's got MS Paint open. And because he, you know, for those of you who don't know, he is an MS Paint engineer. And he can represent anything on MS Paint. So anyway, he's breaking down Battle of the Beams in this room full of sewage. And all of a sudden, the sewage just starts draining out of the room. And I don't even need my spelunking gear anymore. The oxygen levels are normal. It's all good. And I was like, wow, this guy and me have to be friends now. This dude's awesome.
Yeah, we gotta be friends. He has no choice.
Dude cleared out a whole sewer with MS Paint.
I will say though, dog, I would have like, dude, if it wasn't for Alan, and dude, honestly, if I think about it, right, Witsit's like the first person that I saw on YouTube and got me into Earth Awakenings, and then I came in and asked him a question or two on like a School and Globers episode, and then I hung out in there, and Alan popped up one day, and that's his spelunking episode he just gave, and ended up getting invited to Ether Cause, and then I went over there and met Alan and Toby, and later Shane. But dude, Alan is the like. Y'all ever been to? I don't know what they call it. Like they got them all over the place. Like Pepper Palace, yeah, Pepper Palace. They got like a store full of hot sauces, right? Like they got like 400 different hot sauces in there. And they got like the little free samples, like come try this, come try, test your might or whatever, see if you can try this hot sauce without dying type stuff. Bro, I walk into Ether Cause and I just see Alan, right? Just sitting atop a giant, like literally a hot sauce. He got the sauce palace going, bro. The sauce palace.
You're saying he's a sauce boss?
The sauce boss in his librarian robes, bro. And I'm like, oh my gosh, where did you get all this sauce? And he's like, well, I made it myself. And I came to find out that Alan has the world's largest etheric library. He's your resident ether librarian, and it is because of Alan that I acquired most of my knowledge of all these topics. I was blessed enough to be able to comprehend them, but if it wasn't for him, I wouldn't know any of this stuff. So, major shouts out to you. I know you like try to give praise and be nice and stuff, but it's only because of you I know any of this stuff, man. So, appreciate you sharing the knowledge. You're the one who's putting all those hours grinding and finding this stuff out. When I got on the scene, y'all are already so far ahead. I didn't even know what ether was, dude.
You caught up quick though, dog. But yeah, thanks for that, man. And on the reverse end of that, you coming in and asking like all these insane follow-up questions that were like so far ahead of what I had even thought. Was like, wait a minute, I need to do more. It's not good enough. So it's like it's crazy because as you started picking stuff up, when I would do presentations, the questions you would ask would just be like things that I hadn't even thought of that were like directly relatable to it and stuff. And you have really good insights and intuition for these topics, man. So you've helped me learn just as much.
And now we're just waiting for a month and a half for actually, bro, yeah, it's almost been 2 months for a month and a half for anybody to offer an explanation of these beams.
These beams. Talking about them beams?
You know the ones.
Them German beams. Yeah, dude. I was
That needs to
talking.
be like a monthly or a bi-weekly presentation until someone comes up with an answer. I mean, I'm still waiting on Boston. I think he left, but I'm still waiting on Boston to. Y'all seen like is it Narnia where they like gather all the kingdoms together for war? Like he's like the flag bearer or whatever the dude is that goes around bear the king like the insignia and like gather all the armies together. Like he's still got to do that for the beams because seriously, man, like we need all the content, all the FE community content creators need to get on this and be like, look, we're not engaging with any of you anti-flat earthers. We're not going a step further until y'all answer this. Because until y'all can answer this, it's flat as heck.
Was that Taboo Conspiracy who was the first to like bring that to light?
Yes, sir. Shout out
He's
to
how
Ben.
I found out.
Shout out
Yeah,
to Ben, man.
I post Taboo Conspiracy stuff on that EA server. People do not like that guy. They will genetic fallacy the shit out of him. It's like, oh, it's Taboo Conspiracy. I guess I can't look at the video, or I don't know why. I don't know why. He seems like such a genuine guy. He does like tests with his wife.
Dude, super genuine guy. And when he gets things wrong, like he makes retractions, takes the videos down and stuff, he's not about, presenting dog shit information. Good dude.
Someone said there was a video
Battle of the Beams.
Someone said there was a video that he took down because he thought he was wrong, and then someone showed him that he was actually right, and he didn't keep the video, so he couldn't put it back up. I don't remember what video though.
I really like his video on shadow sets, dude. That's one of like the most simple proofs.
Shadow sets in the Battle of the Beams are absolute bangers, dude.
Yeah, that might be the next one that we're gonna have to cover, these shadow sets. I think that's the first time that I heard of that argument from.
I was literally about to ask you next sentence out of my mouth was gonna be sacred. Do you know what shadow sets are?
I know, yeah, man. We're gonna have to cover that because them predictions ain't predicting.
Yeah.
It's not a complicated topic. It's literally probably like if there's a scale of 1 to 10, it's probably beginner level like 2. It's probably like a 2 out of 10, like difficulty level. It's just go ahead.
I was gonna say it's the completion to sunsets, right? Where it's just like you can't explain a sunset. It's like you can't explain a shadow set. Why don't we meet in the middle?
The sun. They say the sun goes below the ground because it's a ball, right? Sacred. Dude, you know what? No, let me do this with you, Sacred. You're so good at moderating. Like that conversation with Omni, I literally like I DM'd Alan. I was like, dude, Sacred is cooking him right now. I'm gonna sit here and be silent because he just like making him answer questions. So let me do this with you real quick. It's super simple. All right. So if the Earth's a ball, every day at sunset, the sun goes below the ground, right, Sacred?
In the current framework.
Yes. Yeah. Okay. So anytime the sun goes behind an object, that object casts a shadow, right?
Of course, it would have to.
And the angle of that shadow will be determined by the position of that object with respect to the sun.
Yeah, the sun being a light source, right?
Okay. So if at sunset, when you don't see the sun anymore, you don't see it because it sets literally below the ground. Shouldn't the ground cast a shadow?
The ground should cast a shadow relative to the light source, which would be the sun, which should be below it.
Right. So every day at sunset, let's say you're on the West Coast because it sets in the West. Let's say you're at a beach in Cali and you're like, let's say you're at one of the nice beaches. So you got like those 10, 15, 20-story buildings, like big hotel buildings and stuff right behind you. You're just standing there at sea level on the seashore. Sun goes down, right? As it goes down and the top of the sun crests below the horizon, so say it's a super clear day so you can see it, then as soon as that happens, right as it begins to happen, you should see a shadow racing from where the sun is across the top of the water towards you, pass you, go behind you, and then begin riding up the wall of the building, and then go all the way up to the top of the 20-story hotel, and then keep going high, and then rise up into the clouds, and then cast a shadow on the clouds. That's what should happen literally every day, and it never happens ever.
You mean to tell me if we try to demonstrate that, we can't recreate the phenomena?
Yeah, the ground does not cast a shadow. The sun does not shine from underneath the earth upwards onto the ground at the horizon and cast a shadow out.
Globe Earth debunked by a shadow, y'all?
So,
Or the lack
picture?
thereof.
There's a part 2. Go ahead, Proud.
There's a picture of a mountain casting a shadow on the clouds, and I think Sacred, at one point you used that as an example. You were saying that if theoretically this should happen all the time, you should see the shadow of something on the ground when the sun is at sunset, casting a shadow on the clouds all the time.
Yep, that's in Taboo's video. Man, Alan, do you have that link, bro? I always have to ask you for it.
Yep. I'll pull it up in a couple minutes.
But the physical line of the shadow, wouldn't that be considered the Terminator line?
Yeah, well, so I mean, you might have a fuzzy one, but even the edge of the fuzzy part would still be either way, right? But the thing with the shadow on the clouds, that's an optical illusion. It's not real, because you can actually go up on top of those mountains and look, and it's always downwards. But the part 2 of it, maybe this will fill it in for you. So another problem is that before the sun goes below the ground, right? Before it's completely sunset, when there's still a little bit of sun left, regular objects, let's just say, let's say you're on top of a, I don't know, you're sitting in your truck or whatever. Let's say you got a big box. Let's just say just a big box, 10 feet tall, right? And that 10-foot tall box is in front of a 3-story building with just a flat wall, okay? And you're at the beach, right? So this box is in front of a building at the beach as the sun's setting. As that sun lowers down, because the sun is getting lower and goes below the ground, before it goes below the ground, at some point, the sun will actually be lower than the box, so the shadow from the box will actually be cast upwards on the wall behind it. Because the sun is lower, and so relative to the sun, the box is higher, it will be an upward shadow cast.
That is nuts.
But you never see that in real life. Shadows cast from the sun are never taller than the objects that cast them. See, what happens is as the sun gets further away, the relative angle to the sun gets lower, and so instead of casting a downward shadow, the shadows stretch out, and they stretch out, and they stretch out, and eventually they rise up to parallel at sunset, but they never go above parallel, and they would have to if the sun actually went below the ground. But because the sun is always in the sky, it's actually always above us, those shadows will never rise above parallel.
What about, if you were looking at a mountain and you're facing west, right, and the sun goes so-called over the curvature, shouldn't it not cast a shadow? Whereas if it was just going further away, it would cast a shadow of that mountain towards you. But if it was going over the curvature, it wouldn't cast a shadow. So wouldn't that show whether or not it was going away from you, or if it was going around the curve?
Well, if you're on top of a mountain and there's a mountain in front of you that's slightly taller, right, just ever so slightly taller, and or maybe not even taller, maybe you're just on a really tall mountain and there's a shorter mountain in front of you, either way, but it's a little distance in front of you. As the sun goes down, let's say you got a cloud bank, I don't know, right above you, you should be able to see the shadow of that mountain in front of you cast on you, and then rise up the mountain behind you, and then rise up into the clouds. It's the same thing as the box on the building, just a mountain and on the clouds. You don't see that either.
Right, so isn't the Canagoo shadow, doesn't that make no sense on the globe?
Yeah, it doesn't make any sense.
Yo, I put the links to the 4-part series up in the jumbo.
Thank you, sir.
Nice. We're going to need that.